So where we last Hey, so we last left off, we had opened up the webcam with OpenCV, resized our video, loaded Dlib, detected the faces, detected the face orientation, and we've gotten as far as extracting the eyes from orientation. So now what we're going to do is we're going to create a mask of the eyes to copy. We're going to create a list of the positions of the eyes, and then we're going to finally draw the eye mask at all of those previous locations. So with that, let's get started. I'm going to quit out of this and minimize this. The very first thing we're going to want to do is create a new layer that's just going to store the current image of our eyes, and along with that we're going to do an eye mask in the shape of our eyes so that we can copy that out of the frame that we get for each iteration. So in order to do that, we need to know what the size of this frame is, and even though we've resized it to a width of 800, we don't know how high it is. So I'm going to print the frame shape, and the way that you do that is with frame.shape. So let's try running that one more time. And there's our frame shape. So we can do, let's do eye layer equals np.zeros, and then we just pass in the shape. So 450, 800, 3. And then we want unsigned 8-bit integers. And so the way we do that is we say dtype equals uint8. So this gives us values from 0 to 255. So 256 total values. So from 0 to 255, 0 being totally dark, 255 being totally bright for red, green, and blue values. We're going to need an eye mask. And so let's do an eye layer dot copy. We could also do 450, 801, but this is just a good exercise to copy. And then we could do eye mask equals cv2 dot cvt color, right? And then we'll pass in that eye mask, and then we'll set it to cv2 dot color bgr2 gray. Okay. So now we have this new eye layer, which has nothing in it, this new eye mask, which has nothing in it, and then now we should be able to take these shapes. So let's set a left eye and a right eye variable. So the left eye will be from 36 to 42 in that list. So left eye equals shape 36 to 42, and then the right eye is going to be equal to shape from 42 to 48. Alright, so with that, let's actually get rid of this circle, and let's do a cv2 dot fill poly with the eye mask. Actually, I'm going to rename that to eye mask with no underscore real quick. So we're going to do eye mask, right? And then we're going to pass in left eye, and it's got to be in a list, and then a value. So 255 to be totally white. And then we're going to do the same thing with the right eye. So fill poly, eye mask, oh, not eye layer, eye mask, and then the right eye. And again in a list, and then 255 for the value. Now, instead of showing the frame, let's check out the eye mask. So we're going to rename the image that's being shown to the eye mask. So if I hit save, and then we try running it, you gotta wait our 1.5 seconds. Okay, eye mask is not defined. Where did I reuse that? I can find eye underscore. Yep, that was the last spot. Save it again. Let's try running it. Wait that 1.5 seconds, and then there you go. You can see that it's drawing the shape of our eye wherever we are in the video. So if I go all the way over here, if I go all the way over here, you can still see that eye mask. So you could actually use this to draw, if you're really good, a shape with your head. But let's make it so that you just keep track of where the eye is at each position. So that will mean every time that we draw the eye, we'll want to draw it onto a blank screen. So we're going to fill the screen with black. So we'll do eye mask dot fill with 0. So the eye mask is going to be completely filled with 0. So now if we do that, we should have just where our eyes are at currently, which is what we have. Cool. So the next thing we're going to do is we're going to use this as a mask to copy just the eyes from the current frame. So the way that we do that, and this is kind of a bit, tricky, is that we're going to take this eye mask and then we're going to do a bitwise AND with the frame, is what it's called. And so it's going to say wherever the value for the current pixel is true, copy those into it. So we'll see how that works. Let's also, while we're here, do an eye layer dot fill with 0. So it's going to be black every frame, and then when we do our bitwise AND into it, we're going to be able to see just the eyes. So we're going to do a CV2 dot bitwise AND with the frame, right? We're passing in the frame, and then we're going to use the mask of the eye mask. And so we're going to set the eye layer to be equal to it. So now let's change this to be the eye layer. Save it, and if we run it again, fingers crossed, this should work. And it does. This is kind of a really good start for maybe a Halloween project where you just have just the eyes seeing you. If you had a video with multiple eye sets, you could use that. So now we have we've created a mask of our eyes, we've copied it, and so now we need to start creating a list of positions of all the places where the eyes are. So let's jump to that now. So I want to have, again, just n elements. So that means 10, 15, whatever we decide. So let's start by creating a class, and I'm going to name it iList. And it's going to be an object. So def init. So this is what gets called when we initialize it or call it with the parentheses. So I'm going to pass in a length to it, right? And then I'm going to set self.length, well, I got to spell length properly, equals length. And then I'm going to set self dot, what should I call it? Self.eyes. Let's call it self.eyes. Self.eyes equals an empty list. So this is going to create an empty list that we can add stuff to. So next, let's add a way to push things onto this list. Dev push, and then we're going to say self, and then the new coordinates. So we're going to pass a new set of coordinates, one at a time. So if the length of self.eyes is less than the length, then we can just push right onto it, right? So we'll do a self.eyes.append new coordinates. However, if we're already at the maximum length that we want to keep track of eyes, we need to get rid of the first, or it would be the oldest set of coordinates. So let's do a else self.eyes.pop with the 0th element. So that's going to be the very first. So in our case, it'll be the oldest. And then we'll do a self.eyes.append with the latest, the new coordinates. And just one more thing I'm going to add here while we're here is a clear. So if we wanted to clear all of the previous eye locations, self.eyes equals an empty list. All right. now let's create an I list and set it equal to an I list with 10. Okay, so now we have a place to store the X and Y coordinates of where our eyes are out. But we don't really have a way to keep track of where the eyes are, or what the point is, the leftmost point. So the way that we can find that is with a bounding rectangle. And the way that we call that is with cv2.boundingRect. So let's do that now. Let's take this eye layer that we've built and let's do a x, a y, a width, and a height equal to cv2.boundingRectangle with our eye. Well, let's do our eye mask just because it might be quicker, right? So it's going to find the x and y coordinate, and to just check and make sure that works, we could probably copy this from before. Just copied it. Now I'm going to paste it. And so now we should be able to see in our eye, let's do it in our eye layer, how our bounding box works and if it works. All right, so with this, now you can see how it generates the bounding box of where our X and our Y are for our eye. And you can also see it kind of takes the extremities. It doesn't really follow it very well, but it'll be good enough for what we need. So with that, this gives us an X and Y coordinate to push onto the eye list. So we can comment this out. Actually, let's just get rid of this for now. We don't need this stuff. So now we have a bounding rectangle. So we can do ilist.push that X and that Y coordinate that we just got, right? So now we have an eye list with the last 10 places that the box has been for our eye. So with that, we can do for I in reversed, I list dot eyes. Okay, so this is going to start with the last element pushed onto the list and end with the very first or oldest element on that list. So let's do one more thing here. We're going to need to create another mask that's going to just be the previously translated positions. So we have one mask that just has our current eyes. We're going to need to create another mask to track all of the previous positions. So we're going to do translated mask equals I mask dot copy. And then we'll do a translated mask dot fill with zeros, right? And we can go down here, translated mask dot fill with 0. All right. So where's our next for loop? Here we are. So now we're going to create a translated 1 equals to translate I layer. And then we're going to do I0 minus X. I1 minus Y. So this translate takes in not an X and Y to translate to, but an X and Y to translate from the current position. So our I layer is already where it is currently, so we need to subtract the position that we were at to find the difference here. So we're not going to pass in our old X and Y coordinates. We're going to pass in the difference between our old x and y coordinates and our current x, and the old x and y coordinates and our current y. A little bit tricky there. And then next we'll do a translated mask, translated one mask equals translate, and then we're going to translate that I mask. Let's do that I mask by the same previous locations. I0 minus x, I1 minus y. And then, so here we could do a couple things with the translated mask and the translated one mask. We could add them together, but the problem that we'd run into, if you add 255 and 255 in Numpy, you're going to get integer overflows. So instead, I'm going to do a translated mask equals np.maximum. So that's going to take the maximum of either of these. So if they collide or if they overwrite one another, we'll just get 255 back. So we're going to do translated max and then the translated one mask. So again, this is going to take in some mostly black picture, and it's going to have some 255 and some 255. And rather than add them together and potentially overflow, we're going to just take the maximum values. So the 255s from both. Next, we can do our bitwise and copy into translated dot bitwise and translated, and then we're going to do we're going to take out the pixels to make room for these pixels being copied over. 255 minus translated one mask. Okay, and then next we're going to do translated plus equals translated 1. So that's going to add to our translated the new translated 1 image. A little bit confusing, but hopefully it makes sense. Finally, we can set our frame equal to cv2.bitwise and the frame, and then again we're going to take out, so we're going to subtract to make room for the eyes and the places where the eyes were, equals 255 minus translated mask. So translated mask is going to have all the eye positions where it was for the past 10 frames. So we're going to black that out of the current frame with this line. And then finally we'll do frame plus equals translated. So I don't think, yeah, I forgot to, I never defined translated out here. So translated, so we need the translated, so translated is going to store the previous, an image with all the previous images. It's going to build up that image. So we need to do translated equals np.zeros, and then 450, 800, 3, and then let's do a d type equals uint 8. And then of course translated's got to be filled with zeros, so let's do that. Translated.fill 0, and fingers crossed, let's set this to be frame. Fingers crossed this should work. If not, we'll figure it out. All right. There we go. We got our eyes, and now we got our previous frames. So if we want to see what's going on with our other stuff, we can change which frame we're looking at. So if we wanted to see what that eye mask looks like, we just set this to be eye mask. Actually, we don't want eye mask, we want translated mask. Let's save that out so you can see what the translated mask is doing. And if we open it up, you can see the translated mask is keeping the list of the places where the eyes were previously. and it's using that to cut out from the frame the places where it should paste in when we add back in those eyes. Now we can also do just translated, which would be just the list of the eyes, right? So if I save that and we run it, you'll see that it's just the eyes following you around. And of course, we're just taking the current eye that we're copying and pasting around. So whenever you open or close or really close your eyes, you're changing the shape for all of the previous eyes, because again, they're just being pasted. So with that, we can set it to be frame. Let's just do one more thing, kind of a cool feature. Let's make it so that you can toggle this effect on or off. So let's do a let's call it eye snake. Eye snake equals true. Or let's set it to be false, actually. So eye snake is set to false. Then we're gonna have to wrap all of this in an if statement. Or will we? Actually, no. Let's do this. We can do if eye snake, let's show, no, let's not do it. We can't do it that way. Let's just do it like this. If eye snake, right? And then we'll do all this stuff. Oh man, oh man. This was not as easy as I thought. It's alright though, we'll get through this. Tab, 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 no, tab. Yes, yes, yes. Oh, yeah. Right, yep, that's it. And then, so that if statement will be out of there, and if that doesn't happen, then we're here and we're fine. So let's set if key equals s. Let's do a eye snake equals not eye snake. So this will toggle it, right? And so you'll see with this if statement, we just really inefficiently, I'm sure there's a quick command to tab it over in Visual Studio Code, but I normally use Emacs is going to be my excuse. So let's try this. Let's see if this worked. Or if I missed my tabbing somewhere in that terrible long time I spent. Alright, so this looks fine. Let's press S. And there we go. So now, if we press S again, and then we do, okay. So now we can add our clear, and then we should be good to be able to turn this on and off whenever we like. Alright, so let's do iList.clear. Right? Run it. Take a look at it. All good. Now we can get crazy and then get crazy again. Cool. Well, thanks for watching. In the next video, we'll run this through with some existing video, and that way we'll be able to have high resolution with multiple people and multiple eyes being dragged around. So thanks for watching, and I'll see you in the next video. Bye.